Hello, welcome everyone to Dash. I hope you enjoy the keynotes. For me, it was super exciting to see all those new features that they were just announced. But now we have a roundtable that we are going to be talking about scaling Kubernetes. And for that, we have an amazing panel. I'll be moderating that panel. I'm a technical evangelist at Datadog. And just before we introduce our panelists, just a couple of housekeeping items. So we want to make this as interactive as possible. We want to have your questions in. We want to have some conversation going. So please use the chat functionality to talk among you. But if you want to pose a question to our panelists, please use the Q&A button. So you have two tabs in Hopin. You have the chat window where you can chat as much as you want, and we encourage that is happening as we talk. But you also have the Q&A. So to keep things a little bit organized, please keep the questions that you want to pose to the panelists on that Q&A button. The second thing is that we have a couple of polls. So if you go to the polls tab, we are going to be asking you just to know a little bit where are you on your journey with Kubernetes. There are a couple of polls, one around the number of nodes that you have in your clusters. Obviously, you may have several clusters with different sizes, but just pick what it's more or less, what it's the majority of your clusters. And a second one about managed Kubernetes versus non-managed Kubernetes. So if you want to start participating in that poll, that'd be great. So when we start with the conversation, we are able to see those results. So without further ado, I'm going to let these amazing speakers introduce themselves. We are going to go a little bit on alphabetical order. So Jeremy, do you want to go first?
Hello, hopefully you can hear me all right. My name is Jeremy Eder. I'm one of the distinguished engineers at Red Hat and currently one of several architects working on the various OpenShift-based managed services that Red Hat offers. And in the past, I spent many years actually working on Kubernetes performance and scale, including from the earliest days of Kubernetes. So if you were with me at DockerCon in 14 when the Google did the Cube announcement, it's been a long community-based ride since then. We've learned a lot, and I appreciate the Datadog team having me today.
Fantastic, thanks a lot. Laurent, do you want to go next?
Hello, I'm Laurent Bernai. I'm staff engineer at Datadog. I work in the infrastructure organization, and I've been at Datadog for 4 years. And I've joined Datadog when we started deploying our applications on Kubernetes. And the last 4 years have been very interesting in this topic because we started from nothing and now we have hundreds of clusters and tens of thousands of nodes. So we also have a lot of stories to share, and I'm very happy to share them today.
Great. Sandra?
Hi, hope you guys can hear me okay. Sandra Ferreira. Sandro is easier to remember and pronounce. I'm a principal tech and engineer at HSBC. As a bank, right, so we have a lot of regulations that we needed to attend to, and we have even layers of auditing. So we have a internal Kubernetes platform where we can offer this Kubernetes experience for our customers. So we've been tinkering around this for quite a while. My background is application servers and web servers, right? So when we have these 3 layers architecture, web server, application server, and database, one of the problems that we have is like how to migrate those big boxes where the application server reside, how to scale, add more nodes or remove nodes. That was always a problem, right? So when you start looking at Docker initially, right, it's very easy when the containers is very attractive that you can bring it up and bring down instances, right? And then when we start looking at, okay, how do we make our customers consume that? So they have to SSH to the box, create a whole bunch of files and compose and stuff like that. So that was not sustainable. Like it would be basically more work for me, like in my team. So we started looking at stuff like Kubernetes, where you can create this infrastructure, right? Once you have the nodes and have the proper authorization, right, you can give kubectl and have the customers create manifests and deploy how many instances they want about web servers and application servers. And I'm completely out of the picture of that. I love it, right? So I've been working Kubernetes ever since about 2016-ish when you start this journey, and glad to be given this opportunity to speak here.
Great. So as you can see, we have an amazing set of panelists with lots of experience managing Kubernetes, deploying applications to Kubernetes, and people like that, like Jeremy has been there since the very, very beginning of the platform. So super excited to have them here. So obviously, because of your expertise and your experience, one of the things that we want to know is how you go from starting with Kubernetes to scale. But I guess the first question would be, what is Kubernetes at scale for you? Because obviously, this can mean very different things depending on the workload that you have, depending on the type of infrastructure that you deploy Kubernetes to. So let's start by that question, and let's do. I'm going to change a little bit the orders to make things a little bit dynamic. For example, Laurent, do you want to start? What is Kubernetes at scale for you?
Sure. So for us, we can start thinking about scale based on the history of Datadog with Kubernetes. So the first scaling issue we faced was related to the number of nodes per cluster. And we started a while back, so Kubernetes was not able to support a lot of nodes. And we reached several points where scaling was starting to be difficult. So first it was 100 nodes, then 500, then 1,000. And I'd say today, when you start to have clusters with more than 1,000 nodes, it starts to be a bit tricky, and you have to think about it. And then now our biggest issue is the number of clusters, because we have clusters of standard sizes around up to 3,000 or 4,000 nodes. And the new challenge is now the number of clusters we have to manage, and the number of clusters we'll have to manage in the future.
Cool. What about you, Sandra, on your bank? You have most of them are internal users. What's Kubernetes scale for you?
Right. So for us, right, so Kubernetes is, we think of it as an ecosystem, right? Because just Kubernetes is not enough, right? We need a lot of stuff. So we need to think about ingress controllers. We need to think about secret managers, container registry. So all of that. So it's basically an ecosystem of distributed systems, right? So it scaled that stuff, like not even like, how many number of nodes, but how many pods per node, so my memory, and it is a lot to think about, right? So all of those is important for us, like specifically internally. And one aspect is also important is people, right? It's not only technical how to scale stuff, but people. How do you manage a team? How do you make it possible to have a handful of people manage these humongous infrastructure and systems?
Cool. And in your case, Jeremy, you have a special case with Red Hat because you are both a vendor of Kubernetes with OpenShift, but also you also provide those clusters. So you have two different views of what might be Kubernetes at scale. So can you talk a little bit about it?
Sure. I mean, to me, the hero numbers, so to say, are fun from an academic standpoint, but they are often more trouble than they're worth to get kind of. And I know this because I've got the arrows in my back. I remember going through a project to get to over 2,000 nodes. I think we're going back 4 or 5 years now, and it was absolutely brutal. We realized how much was actually missing to do it right, and have since then been on a journey to be able to say that we support those types of numbers. But in reality, the demand for that number is very small, very small. It's there, but it's very small. In reality, most what we're finding is customers in in the 100 range, but having multiple clusters for a variety of reasons that are often non-technical. I think what's the most important to me is that folks realize that you're, not to forget that you're, most of us work in a business here, and, you have to pay attention to your cost to serve. What is your overhead? So what I like to think about when I think about scale, I think about the right size cluster for the job and leveraging the elasticity that the majority of public clouds offer, and even some, more sophisticated people doing with bare metal, around elasticity and having the right size cluster, whether it's vertically, larger nodes or many smaller nodes, the right size for your workload. One of the things we ran into in the very earliest days of Kubernetes was our customer set at Red Hat had different use cases than the original design decisions being made around both Kubernetes and the container runtimes. And so we had to take on some scaling numbers that were out in front of the ecosystem in order to actually have something useful for the customers that we had, and the asks that they were making. And so from a vendor standpoint, we took on some risk there and have since brought the community with us. For example, supporting hugely dense individual nodes. I think, we're definitely supporting 500 pods on an individual node right now for people that are bringing machines that have multiple terabytes of memory on them and hundreds of cores. That's a totally reasonable number to be asking on such big iron, essentially. So scale to me is about being right sized. It's about cost efficiency, cost to serve, and taking advantage of all of the Kubernetes features that make scaling a little bit easier, like machine health checks and cluster autoscaler and various autoscalers like VPA and HPA.
Cool. I really like that that answer. Like it's about the right size for the job, and as you said, having things like autoscaler for horizontal as the scaler or vertical or the cluster autoscaler, it's critical to make this happen. So going back to the poll, so one of the questions that we asked was the size of the clusters that people were using. So it seems like the majority, like 42% of respondents have between 21 and 100 nodes, which is started to be pretty big. But 19% are between 100 and 500. So there are people running already big Kubernetes in the audience. So that's going to bring a lot of interesting questions from the audience as well. Nobody replied that there are over 500 nodes. So there is still scaling opportunities over there. Good. So the other thing that we discussed when we were chatting among us is how different might be to work with a managed Kubernetes solution and a non-managed. And by non-managed Kubernetes solution, what we mean is that you manage your own control plane. And managed Kubernetes, we mean one of these solutions that the platform and the clouds offer, where they manage the control plane for you. So, for example, Jeremy, going back to you, what do you see the benefits between one or the other?
So, just like any other managed service, people are looking to reduce their time to market. They're looking to focus on their undifferentiated heavy lifting, or not focus on undifferentiated heavy lifting. And so, Red Hat has gone the partner route, which we've done for our entire history in building services, first class native services on both Azure and AWS. So wherever the customers want to do their cloud business, if they've already got, a presence on an individual cloud, we also have a GCP based offering. They can bring our software stack with them. That's the idea. So our team is responsible for quite a lot more actually than the control plane, which is one of the differentiators, without getting into too salesy, because I'm intentionally not in sales. we do a little bit more than just the control plane, and that's kind of one of the things that makes our offerings unique. So anyway, that said, managing a control plane of many hundreds and thousands of Kubernetes clusters is in itself a black art that's tied up quite often in silos of expertise within each cloud provider, and they're currently differentiating on that. As you can imagine, Red Hat's point of view is very different, and we've launched a project called operate-first.cloud that attempts to bring all of our SRE related knowledge, not just OpenShift, but everything else, into the open and build a community around it. So and it does not have to be around our managed services either. Any operational or SRE kind of knowledge. Someone told me it was, that's Stack Overflow for SRE. I said, I guess there certainly is no. That was actually a question that came up at SRECon last week was, why don't we have Stack Overflow for SRE? And I said, well, you know what? We've got something. Go to operate-first.cloud and you'll see what I'm talking about. And there's a whole community there. So anyway, the managed services, like we're going to offer them at Red Hat. We offer them at Red Hat. But also we're intentionally upstreaming all of our operational knowledge to keep with our culture and to also democratize operations for our on-premise customers as well, who always are asking us, hey, how do you do this? How do you do that? And I'm glad to talk to you all today to share some of those things. So for example, we had to put a bunch of guardrails in place to keep so we do a 3.5 nines of availability, SLA on the control plane, the API server in particular. How do we do that? The key pieces are that we have custom RBAC, which is guardrails, which you can remove, but there's guardrails in there. We have a whole bunch of webhooks that attempt to do the right thing to protect the API server, and then also we don't permit. Essentially, what I'm saying is we're a little bit more prescriptive than having your own cluster that you manage on your own, where you can juggle switchblades if you want. All good, right? So that's my point of view on managed. And I did want to call out the fact that the operations aspect of it is a differentiator for different cloud providers. But from Red Hat's point of view, we don't intend to go that route.
Good. What about Sandra? Managed or non-managed? What are your views on that front?
That is interesting, right? Because internally we manage an unmanaged Kubernetes system, right? And we package, as Jeremy mentioned, we also are not just a control plane, it's basically all the ecosystem around that to make it useful. And then our customers just come in and with the workload and enjoy. That was echoing Jeremy's previous statement on the last question about the right sizing, right? There was one time when we started this Kubernetes journey, one user came about to like, listen, I need to be able to create my own cluster at will, and I wanted to take full administration of that because I know Kubernetes, I know what I'm doing, and I'm good to go. Like, okay, so one of the benefits to be close to our customers that we can have a little peek on what exactly they wanted to do, what problem they're trying to solve, right, internally. And turns out that every month, right, during a week, they produce a report, a PDF, I believe. And they wanted to make sure that that PDF is available to a lot of people. So what they wanted to do is spin up a cluster, create a whole bunch of web servers, Nginx or whatever, place that PDF there and a whole bunch of nodes and let people access that for a week, and after a week bring it down. Like he wanted to do that every single month, right? And then we say, okay, right, that is an interesting solution, right? But what if you take that PDF and put it to an object storage, right, which you already have internally and is already distributed, and it just give that link to everybody, right? And you'll put it there and it's easier, right? You don't need to have that overhead on yourself to maintain that thing. He liked that idea, right, actually. And he said, and as a bonus, he even told us, like, because we can place that thing in that report in one place, people can go back to the previous month or months back and do a comparison between the reports. And basically, we unlocked a hidden trophy with that.
Cool. So Laurent, in your case, I know that Datadog manages its own control plane. Why you as a team made that decision, and what are the benefits, and what are the consequences as well of doing that?
So it's a choice we made when we started, so about 4 years ago. And the main reason is we made design choices at the time, which made managed services impossible. So to give you an example, we had a very aggressive timeline in terms of migration. And so we decided to move one application from a node in an instance on a cloud provider directly to a pod on a single node. So the design was nodes would in most cases have only one application pod. Which gets back to one of the thing we were discussing earlier in terms of right sizing, right? Because we never had challenges in terms of number of pods per node. However, we knew that we would have very significant challenges in terms of number of nodes. And at the time, no managed offerings was supporting the sizes we were targeting. And so we started this way. We had another constraint, which is we were running on 2 cloud providers at the time. Now we're running on 3. And we wanted the user experience to be extremely similar across providers. And of course, as we were discussing earlier, cloud providers want to provide offerings that are differentiators, right? They want their offerings to be better in ways, which mean the interface is different. So the way things will work will be different, and we wanted to abstract this as much as we could to our users. And this meant not using managed offerings. I think it's something that we could revisit in the future, because as the number of clusters grow and as the ecosystem matures in the community, I think using managed services is something that will be possible in the future for many of our use cases, and it could be interesting as we scale.
Cool. I like it that even though we make some decisions as engineers early on, we are always open to change that. If the platform changes, if the ecosystem changes, there is always room to change. So before we continue with the questions, so the results of the poll about managed versus non-managed. So we are seeing that 70% of the people who replied is using managed Kubernetes, which is in line with what we saw on our containers report at Datadog. Datadog runs a container report every year based on the data that we can see from our users. And in our report, it's even bigger. It's about 90% this year, growing every year. So definitely something is a good solution that cloud providers are offering that more and more people are taking advantage of. So that's fantastic. So let's take one question from the audience. And remember, you can ask as many questions as you want to the panelists on the Q&A button. And so if you have questions that are general, just put the question. If you have a specific question to one of the panelists, just put their name before. So Tom Gates, talking about managed Kubernetes and running Kubernetes in the cloud, talks a little bit, ask about something that it's always some challenging on Kubernetes. It's about stateful sets, stateful workloads. So he's asking in particular about databases, whether it's better to run those in the cluster or using one of these managed services by the clouds. Who wants to take that one?
I can take a shot. So I would say this. It's kind of, to me, the same decision kind of logic flow that you would employ if you're deciding on using managed versus unmanaged in the first place. It's whether you have the skills to do it yourself, whether you have the desire from a business priority standpoint to do it yourself, and whether you can meet the features that the cloud providers are offering. So managed services aren't for everybody. We don't cover every use case. That's part of the gig here is being a little bit more prescriptive. The reason that the number, I believe the adoption of managed services is increasing is because as our services mature, we are covering more and more use cases. And that's great. People are more and more comfortable with using them and so forth. So I think it's the same decision logic. Like I was mentioning before about Red Hat's partnership model, we're partnering with various database as a service providers to offer those sorts of things as a native experience within OpenShift. But being totally honest with you, even internally for the services that we run, we love the cloud provider databases, the standard stuff that the cloud providers offer, and we use them ourselves extensively. So I have no personal objections running things externally to the cluster. It gives me a lot of benefits, actually. In cluster, the best experience we're kind of aware of right now, and I'd love to be corrected on this, but it's around CockroachDB being largely the most mature for an in-cluster stateful database. And they've got operators for Kubernetes and OpenShift as well. So it also depends on whether you need an RDBMS or a document-based database, and the maturity of those offerings on Kubernetes itself. Because you're right, it's not easy to get stateful workloads correct. And I think, maybe I'm biased here, but the operator model seems to be a useful way of making them safer to run on top of the Kubernetes abstractions.
Cool. Thank you.
I can add a few things if we have time on this topic, Ara.
Yes, we do.
Yeah. So I can tell you that at Datadog, we run almost all our data stores in Kubernetes. I don't know if I would recommend it because we do it, but it took us time and it took us a lot of experience building the expertise to do it. One thing that's important and is that it really depends on the database, right? Some of them are easier to manage in Kubernetes than others, especially distributed ones, right? Databases that were designed to be fully distributed are easier to manage than databases that are designed to do active-passive. And you were mentioning RDBMS databases, and yes, this is the type of database we don't run in Kubernetes yet. But we run Cassandra, for instance, in Kafka. So it works. And we had to at Datadog because there aren't managed offerings for all the databases we use. And we wanted to run things the same way everywhere on multiple cloud providers. But I won't lie to you, it required a lot of effort from the teams managing these data stores.
May I, or do you want to jump to another question?
Go ahead.
So because I think you needed to understand that if you deploy a database, there is a lot of understanding of Kubernetes, right? Because the burden of the managing of that database in Kubernetes is going to be on you or your team, right? Because how would that going to be synchronization and log transaction around that backup? So there is a lot of stuff you needed to understand how a database is going to behave in Kubernetes, right? Concept. There is one very well-known relational database, which is MySQL. I don't know if you guys heard about Vitess, that was created by YouTube, right? So basically, they took MySQL, which is not a distributed database per se. So they create thousands and thousands of instances, and they beat that distribution aspect of it, but have multiple replicas, right? And they run that nicely. Actually, we are interested in running one of those in Kubernetes internally. We play around on that, but then we decide for non-technical reasons to move to not to pursue that, right? But it is a very interesting one if you guys want to see Vitess.
Cool.
Developed by YouTube originally.
Thanks for that point. So we will go back to the questions from the audience, but before that, one of the things we've talked about, number of nodes, we've talked about running hundreds of bots per node. But what about services? When we grow in services, and I think services and service discovery opens up another Pandora box here. So Laurent, let's start by you. What are your strategies on service discovery and networking?
So in terms of networking, one of the design choice we made from the start is that we decided to give every single pod an IP that is routable in the network. And we wanted this because we wanted to avoid the cost of overlays. And as you can imagine, at Datadog, we have a lot of network-intensive applications. And also we knew we would have multiple clusters and that sometimes we wouldn't be able to use load balancers or ingresses to do traffic, to route traffic between clusters, and that having IP routables between clusters would help. So we started with that, and this is the solution we've deployed everywhere. But then we get to the next question, which is, how do you discover services between clusters? And this is not something, I mean, I can't tell you that it's solved. We have things that work pretty well today, but we're already thinking about the future. And so we started with DNS, with an open source upstream project called External DNS, where you can register services from the cluster in a zone managed by the cloud provider. And then these IPs are discoverable from other clusters. We're running into issues because we're rate limited, the size of the records is limited, and we've built in-house a solution to make this scalable with the plan to extend the interface to XDS and not only provide DNS, but also XDS, so people can use this to discover services across clusters.
Cool. Sandra, do you want to add anything around service discovery?
Yeah, so in our case, well, as they say, right, it's always DNS a problem with Kubernetes. So one of the things that we do is a lot of education with the customer. So the way we handle is we provide infrastructure, right, and then we work with the customer hand in hand as like educate them how to consume that, so they have skin in the game, right? So this type of administration, how they distribute this stuff that they put on, is on them, right? We guide them, but at the end of the day is their responsibility, right? So we recommend them is stuff within the cluster, right? So communication east west, right? Use what the cluster provides, services internally or service mesh, right? If you want to meet your TLS and stuff like that. If it is north south, right, outside of the cluster, then we usually recommend them to do some sort of API management, right? So they can go somewhere and publish their APIs and make them discoverable like that, right? And then solve this DNS. So basically, it's like we don't want it to be an impediment to them, because service mesh specific, right? If you wanted to do communication external clusters and stuff that is Kubernetes with something that is not Kubernetes, it can become really hairy very quickly.
Yes. Jeremy, do you want to add anything there, or do you want me to go to the questions from the audience again?
Maybe just quickly, we definitely had that same problem mentioned earlier about the raw network versus VXLAN encapsulated overlays. And we found that the majority of customers were totally fine with the performance of an overlay. And there were certain use cases that weren't fine. Telecom use cases come up, financial services use cases come up occasionally. And so what we did was we partnered with Intel to bring Multis, which was their CNI for a secondary network adapter, into, well, not into Kubernetes, but into the open source ecosystem for use. And that's how you handle secondary networks on OpenShift. So you can have a data plane that is line rate and still have your service discovery on different networks. So that's that. We use Core DNS for a daemon set of Core DNS and then a bunch of caches to make sure that you've got low latency lookups that don't leave a node and things like that. And then for Multicluster, the Red Hat engineering team has put together projects called Submariner or Submariner. Not sure which pronunciation they prefer this week, but one of those. and which handles the networking between clusters, and then a service discovery, multi-cluster service discovery called Lighthouse. So if you Google either of those words, you'll come up with the projects that we've got, and those are productized now. Well, Submariner is, or Submariner, and Lighthouse a little bit forward looking. But I agree, this is a problem that has to be solved for a fully mature application that's got like multi-cluster redundancy to it. Absolutely required. So the gears are in motion.
Very good. I got a couple of questions from the audience, one from Tom and one from Wesley around auto-scaling. So Tom was talking about node autoscaler, which I guess is cluster autoscaler. Wesley is talking about pod autoscaling, in this case, what metrics to use for the autoscaler. So apparently they've been using CPU, but maybe they're asking for some suggestions on other metrics that are better for the horizontal autoscaler. Laurent, do you want to give it a try to this one?
Yeah, I mean, it's difficult to answer this question because it will really depend on the application, right? And I know that within Datadog, we use pod autoscaler and cluster autoscaler extensively, but each team is responsible for picking the metrics that make sense for their applications. And I don't think we have, yeah, go on.
No, I think that's a perfect answer. The applications, the metrics are interesting for each of the teams. The teams will know better what are the metrics that they should be interested in.
I think maybe sorry to jump in here. Like, so specifically CPU, right? It needed to. It depends on the application languages and what exactly means by CPU, right? So it's consumption, because Kubernetes has this concept of fragmentation of a CPU, right? You can have a 0.1 of CPU, so needed to understand exactly what is the consumption of that. I had experience with Java from my background, and Java is the opposite. It's very memory hungry, right? It can escalate to like really quickly, and we had an interesting experience with vertical pod autoscaling, right? Because basically what it does is basically kill your pod and adjust memory and CPU, depends what you do it. And sometimes for Java, that is really a bad idea, right? Because you need a really big heap, depends on what the application requires. Every time you do that, it takes a minute or two just for your pod to restart, right? And that can be a problem. So again, it depends, right? You needed to actually have a look at it, and that's one interesting aspect of Kubernetes, right? Because the application teams, they have skin in the game. They can actually have that responsibility and have a look and troubleshoot that thing.
Yeah, and it's basically very related to this culture shift of teams owning their services in production, which I think is super important to make this work successfully. Okay, so we have another question from the audience, specifically for Jeremy. Mahmoud is asking, and thanks again for bringing those amazing questions to the table, is asking any good recommendations for how to go about right-sizing my Kubernetes clusters, looking for insight into possible specific methodologies or something like that.
Yes. So besides the easy ones, like having those autoscalers in place, the way that I approach these design decisions is I try to get a sense of what our cost needs to be, our cost targets, and I work backwards from that. Because if I have the most elegant technical solution, but it's 10 times the price of what we can sell it for, there's no point to having a right size cluster because it's too expensive. So I do tend to bias myself towards getting the right kind of requirements in from a business standpoint first. Where I'm willing to overpay, how about I start with that? Where I'm willing to overpay, is on the control plane resources. And I will always bias towards having more than less, because anyone who's dealt with even day one Kubernetes stuff, you can fly etcd right into the side of a mountain pretty easily if you don't give it the right resources and disk performance. So I will overpay on that and hopefully make it up on having nodes come and go. One thing I'll mention is we haven't had a lot of requests for exotic configuration. When we first launched the autoscaler capability, I was thinking we're gonna launch it with some. It'll be a prescriptive thing, and then we'll wait and see if anybody asks for anything exotic. Nobody's asked, and what they have asked for is custom metrics for the HPA, which I totally get. We use it ourselves. So, for example, I can keep the cluster super small as long as the application fits on these bigger nodes, and I'm scaling the application to meet my SLOs. And so that's where all of this comes in. So, for example, we've got an SLO for latency of the average read size from a particular external dependency. Okay, we've got microservices. We're fishing out some other information from a different data store. When we started load testing, we found that pipe was too small. It wasn't the other service's problem, it was our problem. And so what I'm getting at here is load testing is you can't skip that step because you need to kind of know where your stuff's going to fall down. And from there, we worked backwards to say, okay, this is the custom metric that we need for this particular application profile. In that case, it was HTTP requests in flight, I believe. It's some HA proxy metric. And we worked backwards from there to get the right values for HPA in our world. And you know what? We didn't need any other customization other than getting the requests and limits right. So to summarize, I always have to, and maybe this is just me, but I always start with the business constraints so I know what my budgets are for the various architectural decisions. Next step is I establish a set of SLOs so that the users remain happy and we have some flexibility to experiment or drive features more quickly if we're able to deliver reliable systems. And then from there, all of the normal Kubernetes stuff, and I'm trying not to hand wave, but if you're not using these autoscalers, you should. They're very mature at this point and in production in a variety of systems. We use them ourselves extensively. They work very well. I hope that answers your question.
I'm sure it does. Very good, very good answer. Thanks, Jeremy. And you mentioned something about etcd as an example of things that can fail very, very quickly in a Kubernetes platform. So we've been talking about metrics, application metrics, that the teams are the best to decide what are the important metrics. But what about observability of the platform itself? We are at Dash. This is an observability conference. So what are the things that we need to take into account when bringing up an observability strategy for Kubernetes? And I think this is very important, no matter where you are in your journey with Kubernetes. The earliest that you start is the better. Laurent, for example, do you want to give us some recommendations of what are the things that people need to pay attention to?
Yes, definitely. And all of the metrics I will mention are based on things we learned the hard way when we scaled our clusters. And I'm sure Jeremy and Sandra will have fun stories too. I think the first thing would be to start with simple checks, like making sure your control plane is answering, so making sure the API server is available. And it gives you a good insight of what your users are seeing, right? And then another thing is to look at how controllers are doing in the cluster. So the size of the queue of the different controllers, because when they have too much work to manage, it means everything slows down, and it's usually an indication you have a problem. And finally, of course, etcd. And I'd say for etcd, the most interesting indicator is probably disk health. So the time it takes for IOs to finish, right? Because when the number of pending IOs, the queue size rise, or the latency rises, it usually indicates that your cluster is starting to be in a pretty bad shape. And the last thing I will mention is the thing we've found to be the most interesting is audit logs, right? So audit logs are logs giving you the history of everything that happened in the cluster, all the API calls made to API servers, and we find them extremely valuable because they help us understand what went wrong and what workloads actually destroyed the cluster at one point. And it helped us identify many misconfigured controllers that were, for instance, watching all pods in the cluster and just destroying API server and etcd. And it's been extremely helpful to instrument audit logs to help debug problems and prevent them. So yeah.
Yes, prevention is definitely important as well. So we are wrapping up. We are out of time. So I'm going to go quickly throughout everyone. Sandra, do you want to give us just one recommendation for people starting on the Kubernetes journey? If you could give one in a couple of sentences, we don't have time for a lot more.
So very quickly, I think is like nowadays we have like tons of tutorials and trainings out there, right? So I think what I say is like be curious and have fun.
Fantastic. Jeremy, any recommendation that you would give people starting their journey?
Keep your focus on the user experience. That's all that matters in the end.
I like that one. Laurent?
Think about training new users because Kubernetes is very difficult to grasp when users start using it.
Good. Focusing on the customer and training your users and reading and be curious. I love those recommendations. So thanks a lot for everyone for coming, for the amazing discussion that we had on the Q&A section. Thanks, Laurent, Sandra, and Jeremy for participating in this panel. It's been great listening to your expertise. So thanks again and enjoy the rest of Dash.